This video is for class 8 physics and we were solving the numerical problems from the chapter energy. We had done till number 3. We had done all the numerical problems regarding the work. In this video we are going to solve question number 4, 5 and 6, which is on the potential energy, right, which is the numerical problems on the potential energy, and we need to use the formula U equals to mgh. So let us start with number 4. Question number 4 reads as: two bodies of same masses are placed at height h and 2h. Compare their gravitational potential energy. Whenever the word compare comes, we are supposed to find the answer in the ratio form or in the fraction form. So let us try to understand the question and then solve it. So coming to the solution of number 4, there was a condition here, right? We can present the condition in the diagrammatic format here. There are two steps, so we can assume two buildings, okay, where one object is kept on the lower height, the other object is kept at the higher height. Both will have the mass m because they are similar bodies. Let this height here be h and the bigger height is 2h, right? I hope you understood this. This is the condition. Now from this condition we are supposed to find the potential energies of each body and then compare them, right, using the formula U equals to m into g into h. Okay, let us try to find the potential energy of the first body, which is u1 equals to m into g into h. u1 equals to m into g into h, where g is the acceleration due to gravity, as you all know. Now the first potential energy, or the potential energy of this first body, will be m into g into h, right, because mass is not given to us, so we don't have any numbers to represent them. Now we can find the potential energy of the second body. Now for the second body, height given to us is 2h, right? Now since U, which is the universal potential energies formula or gravitational potential energies formula, U equals to m into g into h, right, as you all know. So the potential energy of the second body will be u2 equals to m into g into 2h. Why 2h here? Because height given to us is 2h. Now solving this particular here, we shall get u2 equals to 2mgh, right? Now we have the values of u1, which is the first potential energy, and the value of u2, which is the second potential energy. Now we are supposed to compare them. Let us try to compare them. Now comparing the potential energies, by mistake I have written here P1 upon P2. Okay, it should be u1, that is the first potential energy, upon u2, which is the second potential energy. The value of u1 was m into g into h, which I have written here. The value of u2 is 2m into g into h. So m into g into h and m into g into h gets cancelled. Hence we shall get a fraction which is 1 upon 2, and which can be written in the ratio form, which is 1:2. So hence this is our answer, 1:2. I hope you have understood the numerical problem. Now we can go to number 5. Question number 5 reads as: find the gravitational potential energy, that is U, of 2.5 kg, where mass is given to us, kept at a height of 15 meter. So height is also given to us, which is 15 meter, and the force of gravity on the mass of 1 kg is 10 Newton, which means acceleration due to gravity, g. So the value of g here, this line here, was explained in question number 2 in the previous video, right? So the value of g becomes 10. So let us try to solve this question number 5. Coming to the solution of question number 5, mass given to us is 2.5 kilograms, height is 15 meter, whereas acceleration due to gravity is 10 Newton per kilogram. So using the formula of potential energy, which is U equals to m into g into h, right, replacing the values of m, g and h. M was 2.5 kilograms, where I have removed 1 point and 10 comes to the denominator, multiplied by 10 Newton per kg into height, which is 15 meter. So after the cancellation here, 0 gets cancelled, right? So 25 multiplied by 15, we shall get 375, and here Newton into meter will give me joule. Hence my answer, potential energy becomes 375 joule. Now going to question number 6. Coming to the question 6, the things given to us are the gravitational potential energy stored in a box of weight of 150 kg. So weight is given to us, that is force is given to us, which is 150 kg, is 1.5 into 10 to the power 4 joule. So this is my potential energy U given to us. Find the height of the box. So you're supposed to find the height. So height is question mark. So here I said I am supposed to use the formula U equals to M into G into H. So here I am supposed to use the formula U equals to M into G into H, right, where U is given, G and M is not directly given, so we have to find them first and then at last find this height. Okay, let us try to solve this question. Coming to the solution of number 6, the given things are force equals to 150 kgf, right, and as you all know 1 kgf needs to have 10 Newton, which is also given in the question. So therefore here I am converting force into Newton by multiplying this 150 here by 10, this 10 here. Hence I'll get 1500 Newton. Okay, so I have just converted this kgf into Newton. I hope you have understood till here. The energy which was given to us, which was potential energy, is 1.5 into 10 to the power 4 joules, and height was question mark. Now potential energy stored in the box, right, should be equal to the work done on the box, because this comes from the theory of the potential energy. So when you carry the box to a certain height, which I need to find, right, some energy is stored in that box in the form of potential energy, in fact gravitational potential energy. So here what I have just written is potential energy needs to be equal to the work done, right. Now as you all know, the work done has a formula W equals to force into distance, right. So if I multiply force and distance, indirectly I'll get potential energy. So force is given to us, distance I need to calculate. Okay, replacing the values of the given things, which is potential energy is 1.5 into 10 to the power 4 joule, equals to force, which was 1500 Newton, and into height. Okay, the distance becomes height. Now after the cross multiplication, as you all know, this 1500 comes to the denominator here, right, and then what I have done is I have removed one decimal point, so 10 comes here. So this 0 can cancel this 0, this 2 zeros here cancels this 2 zeros here, and 15 can cancel this 2 15s one time each. Hence I'll get therefore, right, therefore H is equal to 10 meter, right, because joule upon Newton is meter. I hope you have understood number 6. Let us go to number 7. So this number 7 is for your homework. That means you please do it by yourself. Okay, number 7 try to do by yourself. It's like number 6. Okay, but number 6 is much more complicated. Here you just have to use the formula U equals to M into G into H.